Hello, hello. Oh. Hi, everybody. Today I'm going to work on more of the file system API. I think I'm on a good streak, I guess. So offline, I renamed everything I wrote with a prefix POSIX. The reason for this is so I think the approach I'll take is these POSIX prefixed symbols will be public APIs, and then we'll also expose type aliases. Let's see. So maybe say let's add a file here. It's called paths.swift. So you do get to use a path.swift, but really it's just a type alias. Type alias path is POSIX path. And then this will change according to your operating system. So most people shouldn't care about this, but it's really easy to discover, let's say, the fact that you're using an alias, right? So that's intentional. So for now, I think that's an okay thing to do. And the real reason is we can have like a POSIX subset of objects, and then we can also have Windows path and stuff like that. And then they get to use different implementations. I mean, that's the easy part. And the real reason is like we can write test against the Windows path, let's say, and then run the test on POSIX. Of course, not everything is testable because we're dealing with native system APIs sometimes, but for the rest of those times, the function that parse out the drive, Windows path part, things like that, we can test on both platforms. I'm not sure if that benefit outweighs the. I mean, is the benefit is strong enough, let's say, to dictate this design. I may change my mind later, right? This does feel like an okay thing to do for now. So that's where we're going. Okay, so what should I do next? So the interesting thing about this is there's a lot of quite a bit of things that should be shared. For example, this little algorithm that takes out the root of a path and the segments in the path is the same on all platforms, right? This universal algorithm. So like this just happens to be a static function, so it's easier to take it apart. And then there's the bit where we parse out the drive. Obviously, we cannot share that because like one of the tests explicitly says, if I have a path like component in POSIX, right, it should not be parsed out as part of the drive. So if you run that through the same algorithm, you would be wrong on Mac OS and Linux. So things like that. Obviously, you cannot share the code. So that's one of the, I guess, tensions in the design is like you kind of have to divide your code up in a way that kind of, so that the code is shared at appropriate times and place. So I think along that line, let's just make a Windows thingy. Windows path. Let's call it Windows, I guess. Then we can make Windows path.swift. And then we'll also make a Windows constant. All right. Yeah. Oh, let me make the font bigger for the stream. Hopefully that's pretty good, right? Okay. All right, so what's in our Windows constant is all these. So that's another interesting thing. Like we need a way to ensure that the interface for these two are the same. So as a user, you should just use this path symbol and this constant symbol in your code, and feel confident that your code will compile on all the platforms. You don't really need to care about the fact that they're two different objects, right? That's the goal, at least. So we need a way to ensure that this interface for these two don't diverge. So that's another interesting thing we need to think about. I have some ideas. Like we use a development only protocol that only during debug builds these two set of objects conforms to, so that if something's missing in terms of conforming to the protocol, we'll get a compile error, and then we won't ship the conformance in production, in release builds. That's one way to do it. Yeah. And then there's also interesting challenges about do you document these public interfaces, or do you also offer documentation for this specific instances because they're also public, right? And if you do both, then there's a duplication. Then you have to think about ways to update them. Or if you don't do both, then you have to think of a way to, I guess when it comes to generating your documentation, you need to think of a way to, how do we take the documentation for the interface and put it up for the specific instances of it as well. Things like that. Okay. Anyways, let's move on. Let's do one thing at a time. Okay. So we're dealing with what? Windows path. Let's do Windows constants. We'll start by copying these constants, right? I assume they're both pretty useful. Yeah, I'll just keep them. And we know that in Windows, the separated byte is the backslash, I guess. Yeah. Okay. Now we can. Yeah, we need a space for shared stuff. I wonder if this will work. This is implementation detail, and it's not public anyways, but it's also shared. So we could have something like a shared constants or something, internal constants. But this is the interesting thing because we'll have a lot of internal things. So should we call it internal constants or shared constants or something like that? Maybe shared constants. Okay, so it's just the namespace is internal, and then we can take the constants that were previously not shared, put it in here, maybe. Oops. And then we can get rid of the other thing as well, which is over here. We'll build this and jump to the build error. Oh, hello? Oh, POSIX constants, sure. This is Windows constants. Ah, here we go. So, this is a little uncomfortable, but in the meantime, it's not a huge deal. What if, I bet there's more, right? There's Swift test. There'll be more build failures over there. Or not. Okay. All right, so what's next? Let's just take this, paste it on the Windows implementation, rename it, and let's go through it line by line and see what we like and what we don't like. We still need to deal with C, so this is okay. We still would deal with Swift strings. This is okay. I think the general architecture is fine, right? We have the symbol for drive, root, and segments. Yeah, this complaint is invalid, so please go away. Yeah, this is where we have a duplicate function. Yeah. So where should I put this? The hardest problem is almost like naming, but it's naming a place, finding a place to put your shared code. Also, I realized these probably also could be shared. Right. This is easy in the object-oriented world because you can just make a base class. Maybe I'm overthinking, right? Maybe I'm overthinking. Just make it give it its own file. Yoink. Paste internal. Hello? Okay. Path. Oh, parts. Okay, let's see. So this should be. We can also make. Let me think. So we can also have a box object, I guess. Box.swift is a final class with a content generic, and inside is literally just a var of content. Right? Let's make it optional. Oh, actually, no, just content. So now we have this box. We can get rid of the parts cache. Parts cache now should just be a box for optional of path parts. Does that work? Let me think. No, it should take a initializer, I guess. Content is content, self.content. Okay. All right, so here we'll have to do it with neo. And we have to rename this a few times. Path parts. Content, I guess. There we go. Okay. I'm getting a little annoyed looking at this error, so maybe this could fix it. I don't know if that rebuilds the index or not. Maybe it did. Okay, so now I can delete this as well. Probably, did I delete it over there as well? Okay, I did. Okay. Delete those. Now we can go through this file and find parts and name it path parts. And probably want to put some word barrier between them. What? See, that's why I wanted the word barrier. This will be the box of a optional of a path parts. Uh-oh. There's no way that just worked. Yeah, parse path parts. Parse path parts. Say that quickly 3 times. All right. Oh, wait. Swift test. Oh, there we go. Content. Okay. So that's pretty interesting. I think so. I want to stage these for sure, and then that includes something changed here. Shared constant, sure. Path parts and path. I think these are all okay. All right. So what was accomplished here? Oh, not here. Up here. Move some out from POSIX. To share it with window. Okay. And then we created Windows path, and then we have more shared logic to deal with. Yeah, it's really nice that we have this parts sub-object because it serves as a natural namespace for example, this part, right? That's really, really nice. It's would be almost nice, just as nice. If we have another shared object to share the rest of the stuff. For example, this bytes thing looks promising. I don't know how well this works. Extension bytes. Can I do this? I can. Okay. Let's give it an initializer that takes yeah, I can take this guy. Right? And then bytes. This will be self. Everything else should be okay. Okay. And now we can just say self.bytes equals bytes C string. Oh, okay. So let's do that. I'm gonna make these internal. Okay, nice. Yeah, this shares so much. There's so much shared logic here. I don't mind having this namespace take some of it, but also the shared fact that all right, let's move. Let's before I complain too much. Let's also figure this part out, I guess. Yeah. I think I have a plan. Okay, so let's take this. So this could be a initializer for path parts. Or rather, let's just keep it a static function for now. And then for now. But obviously, like, this makes total sense to be an initializer. Actually, yeah, it makes a lot of sense. So let's do init, take care of this, and then here we can simply say I don't need these anymore. Actually, drive can stay here. Drive equals this. Aha, see, this is where things gets interesting, because now we're dealing with POSIX constants. So maybe we can use our constants instead of POSIX constants. Right? So separator bytes is separator bytes independent of platform. So now I remove the declaration of the local root variable. So this root should mean what we want it to mean, okay, which is our own stored property root. And then the segment thing would be, simply like this. Then we don't need this anymore. And I'm hoping this will compile. Or not. All right, so this means parse parts. I can just delete this now. Let's comment it out for now. And here I can simply say path parts bytes, something like that. And we have 2 copies of this, I guess. So we can get rid of this as well. Pass parts. Nice. Did everything pass? Okay. Nice. Okay, that kind of works. This is Windows path, and that is POSIX path. Okay. We just need to make sure constants are aliased correctly for different platforms. This is pretty interesting. So I'm thinking maybe I can have this constant thing be a real concrete object, and then have a sub-object that has the rest of the platform specific symbols, and then use something like a dynamic member lookup to make this nicer. That's one way to do it. Or maybe, basically I'm trying to get rid of this file, right? So instead of doing this, maybe I can simply just make an extension on constants, and it doesn't matter which one it end up to be by aliasing. It's always available, right? So this way I can delete this guy. And then when we compile, we'll fix the error saying this. Okay. All right, that works. Pretty nice. And here is where we add our Windows logic. Now let's take another look at this path thingy. I feel like I'm removing the division between Windows and POSIX little by little. It's like undoing it. Because now I'm thinking, why can't I have one copy of all of these logic as well? Oh, no, this is bad. This is big bad. Yeah, this has already been abstracted away. Bytes, C string. Here is bytes, string. Yeah, bytes string, something like this. Hey, okay, there we go. All right, so still, now if you just look at this class, this struct, and this struct is essentially the same. These two files should be identical now. And that's a bad thing, right? We don't want that. So should I keep them separate, or should I unify them and remove with this alias? Right, that's the thing. I'm torn. Right, let's remember what I said in the beginning. For certain path operations, it would be nice if it can be done on the other platform, right? So if you really want to do something about a Windows path on Mac OS or a Linux machine, you should be able to manually create a Windows path. Okay, fair enough. And that should be a feature. Right. Okay, so how should we do this, right? We can do it. I'm thinking of some protocols approach is possible. What's the user experience like, right? Let's say I want to do the thing I just talked about. I go create a Windows path. What happens on Mac OS if I call the operations that requires a Windows API to implement? Right. Obviously, the answer is you shouldn't be able to call them at all. So what's the set of objects we're playing with here? So the more I think about this, the more I understand how Python's organizing this, right? Python has pure path and path. And pure paths are the ones that doesn't do system I/O. And when we talk about creating a Windows path on POSIX systems, what we really mean is a pure Windows path on POSIX system. So it looks like we need this thing, this pure path thing, and it will have a subset of functionalities the real path has. Okay, makes sense. Makes sense. And then the real path, it should use pure path as a storage. And then it should offer all the interfaces a pure path offers and more. Right, if we go down this approach, having things like classes is really nice. Otherwise, it's a little nasty to forward all the things a pure path offers in a path, right? And pure path can be, yeah. Yeah, so it'd be really nice. It'd be really nice if a path is a pure path, right? Instead of a path has a pure path. That's what I'm thinking of. Okay. So let's make some protocols and see where it takes us. So we want a path to be a pure path. Okay, and then we want because we want to be able to create pure paths across platforms. Okay, let's write it down. Concepts. Paths should have path objects should be offered in two categories. One, pure path. Two, path. Pure path should be able to be used in any OS platforms. For example, creating a Windows pure path on Linux should be possible and fully functional. Fully, let's not be vague here, operational. Okay, so that's the thing about pure path. So what should be the API, right? On the API layer, you get to create Windows Pure Path, and POSIX Pure Path. And when you do, you actually get the behavioral differences. But if you create a pure path, we'll just give you an alias to your native thing. So that's the easy part. Okay. Now, how do you get a path, right? You can create a Windows path, or you can create you cannot create a Windows path. Windows paths will be invisible on POSIX systems and vice versa. Okay, so let's see. So organization. Organization on a platform, pure path, on a given platform, pure path should be all flavors of pure path should be available. Only the native flavor of path should be available. And for example, Linux, the following symbols should exist at compile time. Pure path, Windows pure path, POSIX pure path, and then path, right? We may not even want to expose POSIX, Linux path. Yeah, so you may use any of these four and you get the right thing. So that's the goal. Okay, this actually really helps. I just need to keep this in mind, right? I really like the fact that you don't even get, let's see. These should not be available at compile time. Windows path and POSIX path. Okay, let's make this happen. Let's try to make this happen. This is a pretty interesting challenge. Okay, I think this also could be the main thing for this stream. It's like we set up this hierarchy. All right, so pure path obviously should be an alias to either Windows pure path or POSIX pure path. Fair enough. And Windows pure path. Yeah, this is where sharing implementation becomes super interesting. Super duper interesting. Okay, so let's say like Windows pure path is a struct. POSIX pure path is a struct. How do we implement path, right? The easiest way is path becoming a struct, and it has a Windows path or POSIX path as its property. And then it has a duplicate set of public interfaces that those pure paths, and then just forward. That's the most straightforward thing to do. It's also kind of ugly, right? Because you're duplicating all these interfaces in terms of just writing out the code, but also the documentation and all that good stuff. So another way to do this is let's think. We could make just two objects, Windows path, POSIX path. And then we make a protocol. The protocol will be pure path representable. And then as a user, you could use the protocol as an existential. Will that work? Let's try it. Let me demonstrate what I'm thinking of in my head. Let's do this. So here's what I'm thinking of. Let me just blow this away. What I'm thinking of, it's something like we have a POSIX path, right? And then we have a Windows path. And they each have their own implementation of each have a bunch of stuff. Okay, bunch of stuff. Have bytes, contiguous array of C-char. They each have this, for example. And then they'll each have parts, blah, blah, blah. Okay. And then we'll have a protocol. The protocol is pure path representable. Okay, and pure path representable will have interfaces such as drive. Okay, drive will be a contiguous array of C characters, get. Okay, things like this. And then, so these are not public. Let me think. Can this work? So type alias. Let me think. Type alias. So, okay. Also, we'll make extension POSIX path will conform to pure path representable. We'll write the drive thingy. Blah, blah, blah. Same thing for Windows. Okay. Now can we say type alias pure path is, let's say, is Windows. No, we can't say it's Windows path because we want Windows path to be so can I constrain this? Can I say this is a pure path representable? No. If it's pure path representable, then it becomes, yeah. So here I really would like any pure path representable or something concrete like that, right? Yeah, I don't like this. I think this is where you want something like a manual existential where you inject a bunch of functions um, instead, right? Okay, okay, okay. Let me think. Let me think. So you would have a thing called, instead of all of this, you can have struct pure path and then I don't know, implementation. Implementation. Okay. And oh no, not even this, right? You would say pure path and then pure path implementation. Okay. And then pure path will have your normal things like this and this. You see, this is okay, except now I lost my... let me think. Right. So this should be a protocol. Pure path implementation, okay? And then we'll have pure path. All right, it'll have all these shared interfaces and whatnot. And then we'll take a implementation generic. We'll take this. And the protocol will define things like how to parse this and how to parse that. And then we'll have a... then we would have a type alias, right? We'll have... okay, we also have things like POSIX pure path implementation, which conforms to pure path implementation. And then we'll have a Windows one as well. Okay, so we have these. And then we'll also type alias the POSIX pure path to be pure path of implementation, POSIX pure path implementation. So this looks promising. We can get rid of this and say Windows. Okay, so now we got our POSIX pure path and Windows pure path. Now, how do we get the next one? The big one, path, right? Also, should a path be a pure path? Now that we have this implementation thing, I can also have path implementation. Let's just do it later. Path implementation. Okay, path implementation can be a pure path implementation. This is where our ASA relationship is. And then we can have a path, right? path, and it will take a implementation, but this time is constrained. Oh, I forgot to constrain this. This will be constrained to pure path implementation. This will be constrained to path implementation. And we're assuming the implementation doesn't require storage, which I think will be okay. Now the only remaining problem, well, we can also have this thing, except this time we can just make a, say, on Linux, on POSIX. Oh, let's say Windows. Windows is simpler. Windows, we can have type alias path equals path of oh, forgot to put in the implementation here, so we can copy paste, remove the purity. Oh, remove too much. So here would be a Windows path implementation. Ah, yes. Okay, good. So this will be a concrete path or something. Pure path, impure path, monad path, IO path, real path. No, real path actually has its own meaning. Let's call this concrete paths. Right. So this is interesting, but we, there's still some unpleasant things in here. Yeah. Because it doesn't solve our duplication interface problem. Yes, a path implementation is a pure path implementation. But these structs still have their own interface, meaning the interface doesn't get inherited. So like a concrete path, for example, will also have to have this, right? Even though internally in here, you'll forward an implementation to something from here. So the interface is duplicated all over the place, which is unpleasant. And then there's the problem of, okay, if you see a concrete path is a pure path, can you convert it to a pure path? Maybe. Like, I don't want to worry about that too much. Okay, it would be nice if these interfaces don't get duplicated. Also, if we're duplicating interfaces, this could be way simpler as well. So instead of having these implementation objects, I can literally just say concrete path contains a pure path. And that's it. Yeah, object-oriented programming without objects, without inheritance, is basically what I'm doing. I mean, this stuff is neat, but I don't know. Yeah. Another part of this is like efficiency. Is this zero cost abstraction? I don't think so, right? It's gonna cost me something. That's an interesting way to think about this, to make the decision. So from that perspective, a simple struct seems the most attractive to me. We're just talking about wasting a little bit of memory. I think it's okay. Wasting a little bit of speed is okay as well, considering we're dealing with file systems and most likely you'll follow up or prefix with some sort of I/O operation, right? You're hitting the disk, so we have quite a bit of leeway here. Quite a bit. Okay, give me 1 sec. Checking something. All right, we're good. Okay. Decisions. So the other way I was thinking of is way simpler, right? It's like you have the pure. I guess I'll comment this out for now. Approach number 1. Approach number 2 is POSIX pure path. Have this struct, and then you have Windows pure path, and then you have, well, these are all public, and then you have a type alias pure path to either one. So let's just pick Windows for our simplicity. So all of these are public, and then you will have a internal. I'll just write the accessor as well. Why not? Public. Okay. Then you have a internal struct for POSIX path. And it straight up just contains a pure path POSIX. Right? It straight up has one of these. Now, like, yeah. Now, let's say this guy has a drive thingy. Let's just call it a string. Why not? This also has a drive thingy. This will also have a drive thingy. But instead of having its own implementation, they'll have to call pure.drive. Yeah. So we'll have a lot of stuff like this. Oh yeah, and obviously, not obvious, but eventually we'll also have public path, and that'll be a type alias to POSIX. Oh, that means this has to be public. It's okay. So this is the simpler path, simpler design. It's just a couple of good old structs with a couple of aliases. The difference is these will be available in all platforms, all three of these. And this will be under a conditional compilation flag, so that on Windows you don't even get to, this doesn't even exist, this guy. And the trade-off is the duplicated interface, which, oh, I guess another one is no, that could be it. That could be the only trade-off. Could be the only trade-off. And internally, we have to figure out this implementation story. But this does present... Oh, this should not be available at compile time. That's also pretty interesting. Yeah. So this actually violates our design, right? This type alias actually exposes the fact that you're using POSIX path, which is not great. Not great. Yeah, I mean, like we can just make a path object, right? One path object, two implementation. I'm not too attached to that. That's not a huge problem. Not a huge problem. Not a huge problem. Yeah, I mean the huge problem is the duplication problem. Other than that, everything is good. Everything is happy. So we essentially have 3 or 4 entirely unrelated objects. But some of it forwards to the other. Yeah. It's not elegant in terms of implementation. It is efficient in terms of implementation. It's okay in terms of user experience, right? For example, as a user, you probably most of the time only care about path. Actually, implementation-wise, we get a point for being able to test across platform for pure path logic. So that's really good. I think this is not bad. Yeah, I just need to mentally overcome the fact that there's some duplication in interface. Otherwise, we're pretty good. Pretty good. Yeah, okay, let's do it. Let's do it this way. So this really is a POSIX. Well, before I commit, Path lib pure path A B C pure POSIX path. Pure POSIX path. Grammatically, that makes more sense too. So let's call this that, I guess. So pure POSIX path. So this is pure. And we'll also rename it here. Pure POSIX path. Okay. And then POSIX constants. It's fine. This will be pure Windows path. Yeah, okay. I'm kind of attracted to the implementation paradigm where you involve a generic here. But this may force us to jump through no, not worth it. Not worth it. Yeah, I'd rather move the whatchamacallit, the protocol stuff into maybe a compile time check in debug builds. Yeah, that's better. Okay. Pure Windows path. All right. And then in our path object, this is just straight up a lie. We actually want to expose a pure path. Pure path. Okay. Path parts. This is interesting because we probably need two separate implementations. The difference being the separator byte. So this is a pretty good implementation because we're type aliasing things away. Unless this specific thing where there's two forward slashes is POSIX only. And there's also an issue of drive, right? Having to do a drive thing, parse out the drive. Okay. I think before I drown myself into these thoughts, let's update everything first. Pure POSIX parts parsing test. Yeah, I'm happy with that. Pure POSIX. Actually, this doesn't needs to change at all. I mean, it doesn't have to have the pure prefix. POSIX is POSIX. Okay, so the only thing that I need to change is yeah, references to POSIX path should be updated. Okay. POSIX path. Okay. Okay, so that's updated. Yeah, so we can then write a Windows parts parsing test, right? So that's good. Then we have the initialization. This also requires similar modification. Now, let's see what doesn't build. Pure path. Oh, pure POSIX path. Ah, okay. So that kind of works. POSIX constants. Pure POSIX path. Okay. Okay, so this is pretty interesting already, because we've kind of let's see. So parse parts. Is there a way I cannot so parse parts, it takes in the bytes, it takes in some bytes, okay. So that part is easy, and it also requires this parts object. Huh. So looks like there's some hope of extracting this, because the parts object is a box, right? So can do box plus extensions box plus, I don't know, pure path. Then we can extend box where content is a content is a, I think, optional of path parts. Okay, so extend this. Box is in scope. Stop lying. All right, and then here we can say we can extract our little lazy logic So let's see. What do I call this? Get or I don't know. Get or create parts. And it takes the bytes. Yeah, it's fine. Let's hope that Swift does the right thing and not duplicate it for us from. Okay. And then it gives us path parts. Okay, and then all it does is, something like this. Except self.content. If cache parts is self.content, then the parts is cache parts. Otherwise, the self.content becomes this. I can probably get rid of the self dot at this point. And also get rid of self dot here. And we should be compiling. Okay. Now I can get rid of this. And wherever I call parse parts, I can simply call parts dot get or create parts. Oh, from bytes. Okay. Okay. Pretty interesting. Pretty interesting. So these interfaces doesn't have a lot of logic. The only thing that's like unpleasant, I guess, is the fact that they're duplicated everywhere, right? So yeah. So at least for now, I can just literally take the same thing for Windows path and paste it in for POSIX path, and nothing should be affected. Let's see if test still pass. So that's actually a bad thing, I guess. Well, I don't know, like a classically trained object-oriented brain tells me this is wrong, but I don't know. Is it really wrong? Get or create parts. Get or create parts. Get or create parts. It calls path parts. And path parts, is where we can diverge our implementation, right? Yeah, I think this is fine. This is fine. Okay. This is fine. Insert meme here. Okay, let's just sketch out the rest of the public interface. I mean, not all of it, but in terms of top level actors. So we have path, pure path. We have alias for pure path. Okay, we have this. Now let's make the path stuff. So what was the plan? Let's consult. So path. So it looks like I would have basically two implementation for path. So how do I make this pleasant for me? Right? We've solved the problem for our users. So how do I make it pleasant for implementer? We have, this is already a lot of stuff for relatively simple code already. So I hope it'll pay off, it'll scale well. We're just writing out all the stuff that we need, all the namespaces, all the internal objects and external interfaces, and then we will just add stuff to it instead of creating more and more later, right? I mean, there's also stuff like permissions and system error objects and stuff like that I need to think about, but those will, they'll be there anyways. Okay, so okay, let's make the path object. So struct path. I don't even know whether I want to share any code. So like I said, path object has a pure path as its storage. So this is where we can start saying, like, if an OS is Windows, else, and if, right? And if it's Windows, it will have a pure path of type pure Windows path. Otherwise, it will have a pure POSIX path. Okay. So I guess there's some value in sharing this, because one function this serves is forward everything the pure path has. Okay, so forward everything the pure path has means it will have a bytes object. You'll have all of this stuff. Okay, let's try it. Let's get it. So this will be a getter for bytes. Easy. This will simply be pure equals Okay, I can do this, right? Init say string. This way I don't have to type the actual type name. Same thing here, pure equals init string. Easy. Here we say pure dot drive. Pure dot root. And then pure dot segments. Pure dot parse. Okay. Nice. So there is some value in sharing this, and otherwise we'll have to diverge it, right? Like if you want to say like implement something that only that use native API, we'll do that in a different file. But this file exists to forward the shared stuff from Pure. Okay. Nice. And next, I will make the other thing. I don't know, the other thing being pure path representable. Pure path representable dot swift. And this is a protocol, as the name implies. Pure path representable. Okay, so what is a pure path? Pure path has the following stuffs. All of this public stuff. Pure path representable. So I can keep all of this. No problem. No need to be public though. No need. This will be a getter. And this will be, yep. Just an interface. Interface, please. Oh, this is a getter. So get. Okay. Public. Okay. Get. Okay. Parse is another interface. Okay. Yeah, so the reason I want this, let's hope it compiles. Okay. The reason I want this is something that will make both of the pure thingy conform to. Extension pure path representable. No. Extension pure Windows path representable. Pure Windows path. Right. This will conform to that, and POSIX will conform to that. And the confirmation is quote unquote free. But the important thing is this interface will make sure these two don't diverge, right? And then this will be my point of documentation. Yeah, it's like a header file essentially, except there's also an interface so that is to must implement. So that's nice as well. The only thing left is I want this to be probably only a debug thing. So if debug, right, and then end if. So this thing doesn't exist in runtime or in release build. So to verify that it works, how do I verify that? Oops, what did I do? Pure path representable tests. So this is gonna be a fake test, I guess. It's a compile time test. Let's see. So what do I want to do? I want to write a function here. Even, yeah, that's fine. Function. I don't know. Pure pass. Verify pure pass representable is compiled. All we do here is x equals pure pass representable dot self, right? We take the type, we import Pathos, and we know that it's internal, so we need to import testable. Okay. All right, so that's a problem, right? Pure path representable. Did I misspell this? Pure path representable looks good here. What about here? I know that word looked weird. Okay, so that's good. Wait, this gets built, right? I hope so. So every time we build our test, compile time test. Okay. We know that test is built with the debug flag. Yeah. Okay. It's almost reasonable to say this should belong in the test suite. Yeah, it's okay. So this is here to ensure that the implementation doesn't diverge between these two things. Okay. And then in the future, whenever we need to add new things to PurePath, we will add it here, document it here, okay? And then we'll fail the compilation / test, and then we'll go back to the implementation and add them there, right? And then let's see, when we implement new things, each thing have their own way of abstraction, so that we'll try to remove the code duplication. And I'll also just delete all the documentation here because they are part of the representable documentation. So that's Windows, this is POSIX. Nice. Okay, so pure POSIX path and pure Windows path are both available to users, and in addition, they get a struct called path, and this path it does what the native operating system would do, and you have no choice. Okay. And then we can implement tests for POSIX stuff. Okay, Swift test generate Linux main. I want to do this as well. Okay, so let's checking these changes, review it for one last time, I guess. And then I think that'll be today's stream. Okay. Oops, cached. All right. So we did some wording in README. I don't mind keeping them. Here's a okay, so we made a box object, and we've implemented some logic here where it takes the bytes, and depending on the content of the box, either it returns the cached value or it calculates things according to the bytes and then cache it and then return this value. And then we have we moved the code that creates bytes from string and C string. We moved the constant for the character value that represents the current working directory. We moved the thing, so this is no longer a thing. We made a distinction between pure path and path. So now here's the pure path, and here is the path. Path parts get some code that splits logic. It's fine. Yeah. Basically, this is code that takes the bytes and take them apart. Yeah. And then we have a debug, a protocol that only exists in debug builds. That is our header file, most the most best analogy. And then we have the counterpart on Windows for pure path. And then we have the constant for Windows. And then we update our test for the name changes. We have a compile time test that ensures, okay, let me document this a little bit better. Pure path tests. Compile times that ensures is built in debug builds and related conformances. The conformances ensure consistent interfaces between different conformers, I guess. Make some level of sense. Hopefully I won't regret it when I read it later. Okay. And this is a big change. We've got 250 lines of insertion, and we didn't add any single functionality. Nice. Software engineering, right? What's this? Create pure versus real path objects, public interface. interfaces. Okay. Okay, that's the stream. Thanks very much for watching, and see you next time.